Welcome back, 7th grade team. This is Mrs. Allen again, the math coach at Bouchard Middle School, and we're going to continue our 2-week journey as we're learning about probability. So be sure that you have your supplies for today's lesson, and remember, you can feel free to pause or rewind this lesson at any time. We want you to work at your own pace. And we will begin by reviewing our independent practice from yesterday, when we learned how to determine theoretical probability. So please take a few minutes to check your answers and work on your independent practice. Now, if you have an answer that does not match the answer key, compare the work to your answers to see why they might be different. Go ahead and pause your video now. So today's learning objective is to determine the experimental probability of an event. And our vocabulary for the day is experimental probability and sample space. Please write down your vocabulary words and definitions in your notebook. And we're going to start with experimental probability. Experimental probability is the probability of an event determined by carrying out an experiment or a simulation. Those are your key words, an experiment or a simulation. And we use a series of events that have already happened to make a prediction. The formula looks very similar to the theoretical probability formula we've been using over the past 2 days. The difference is that it occurs after the event has taken place. So to find the probability of an event, we write a ratio with the number of times the event occurs to the total number of trials. Sample space represents all possible outcomes for an experiment. The sample space is another way of saying your total possible outcomes that appears in the denominator of your formula for experimental probability. Let's look a little more into experimental probability.
We have John here, who's trying to get ready for an upcoming basketball game by practicing his shooting. We'll keep track of how many he scores and how many he misses. All right, he scores his first shot, so we'll put 1 under scored. Then he misses his second, so we'll put 1 under missed. He scores his third shot, so we'll put 2 under scored. Let's pretend that John does this 25 times, and he scores 20 times, and misses 5. How do you find the experimental probability of him making his next throw? In this lesson, you will learn how to find the experimental probability by creating a ratio. So let's review. If you were asked, what's the probability of this spinner landing on blue, you would say the probability P of blue, our desired outcome, which I'll write as B, equals the number of outcomes that result in blue over the total possibilities. So there's 4 equal outcomes, and 1 of them results in blue. So 1/4 is our probability. Let's go over a common mistake students can often make. When dealing with experimental probability, you might be asked, what's the probability that John would miss his next shot? We're just talking about the basketball problem. And a student might say the probability of him missing his next shot is 5/20. This is actually incorrect because the denominator needs to have the total number of trials. And there aren't 20 trials, there's actually 25 trials because he scored 20 times and missed 5. So add those 2 together and you get 25. In this lesson, you'll be able to tell the difference between theoretical probability and experimental probability. Let's take a look at an example by using a die. If we wanted to find the probability of this die landing on 2, we would find the number of ways the event can occur over the total possible outcomes. So the theoretical probability of this die landing on 2 is 1/6, because there's 6 total possible outcomes, and 1 of them is how a 2 could occur. Theoretical probability is all about what should happen. We're using our mathematical knowledge to create what we think would happen if we were to try rolling the die. Now the difference with experimental probability is you actually do the experiment. You actually throw that die. An experimental probability is given as the number of observed occurrences over the total number of trials. So if we were actually rolling a die, and I'm trying to figure out the probability of rolling a 2, I could say that I tried 10 times, and 3 of the times I got a 2. So then my experimental probability of rolling a 2 would be 3 over 10. Let's take a look back at that problem we were doing with Johnny and him trying to score baskets. The question asked, what's the experimental probability that he will make his next shot? So we want to represent that as the probability of him scoring, and we know we're trying to create a ratio. I know that he tried 25 times because he scored 20 times and missed 5. Now, the number of events that I'm looking for was 20, because that's how many times he scored, and we're trying to find the experimental probability of him scoring his next shot. I can reduce 20 over 25 to 4/5. So according to the experiment of Johnny shooting baskets, he scored 20 and missed 5, and that experimental probability of him scoring his next shot is 4/5.
So, as we've learned from John and his basketball experiment, experimental probability is determined based on an experiment. So, I want you to practice with an experiment created by one of our own learning partners here in the Greater Richmond area. Meet Marvin Holmes III, a rising senior at Varina High School. He is the punter for the Varina High School Blue Devils. His role as the punter is to put the other team in a position where it is harder for them to score a touchdown. So he is using a series of punts to make a prediction about his ability to punt a certain distance. You will answer 2 questions based on his experiment. You'll need to pause the video to see the questions. Resume the video after you've answered the questions to see how you did. I will see you in a few minutes. So as we see from our learning partner Marvin, probability is everywhere, and it's in so many things. We make decisions based on probability all of the time. All that we are doing now is adding numbers to it in an effort to be more precise. And remember, our objective for today is to be able to determine the experimental probability of an event. So we're going to go ahead and take a look at a problem together. So say you have a deck of 52 playing cards in a box. You randomly select a card from the box, record the suit the card belongs to, and put it back into the pile. You repeat this experiment 40 times. The table shows the result of the experiment. So if you notice on the right-hand side, we have a table that shows the result of our experiment. We repeated the experiment 40 times. Sometimes we will see a table created for us. Sometimes it would just be a word problem. But what's important about what we know with this particular example is an experiment was conducted, and the problem tells us that it was conducted 40 times. Sometimes we might not see this, but we will have the frequency in our table. And so what we can go ahead and do is write total at the bottom of our table and write our total frequency, which in this case is 40. Now, based on the results of this experiment, and this is what makes it experimental probability, we've conducted the experiment. We want to create a probability model of selecting the given suit from the box. So again, the numbers that we are selecting is going to be based on the experiment, not based on what could happen, but it's actually based on an experiment being conducted. So we look for the frequency of selecting hearts. We know that hearts was selected 16 times out of the 40 total outcomes. And so we'll write our fraction, 16 over 40. Spades, a spade was selected 8 times, so that's 8 out of 40. Clubs were selected 12 times, 12 out of 40. And diamonds were selected 4 times, 4 out of 40. We can go ahead and simplify these fractions by finding our greatest common factor. So this would simplify as 2/5, 1/5. 12 out of 40 simplifies as 3/10. And 4 out of 40 simplifies as 1/10. So for our probability model, we are simply just writing the experimental probability as a fraction in this case. Now I want you to try an example. So pause the video and allow yourself as much time as you need. Remember, we all can do the math, we just do it at different speeds, and that's okay. Take as much time as you need. Go ahead and pause the video now. Welcome back. So let's check your work based on the answer key. So notice that we had to add up our tallies to calculate our cumulative frequency, which is 11. It looks like 2 tally marks, but it's actually the number 11. Did you notice that the probabilities for not purple and red or blue are the same? Why do you think that is? I bet you have it correct. The colors that are not purple are red and blue. So therefore, those probabilities will be the same. They represent the same values. So as we prepare to conclude today's lesson, let's revisit our learning objective and our key concept. So our learning objective was to determine the experimental probability of an event. And we learned that experimental probability is determined by carrying out an experiment or a simulation. Now it's time for you to complete your independent work to strengthen your ability to apply your understanding of experimental probability. Complete the practice problems located on your Week 7 learning plan for Day 3. Be sure to justify your answers with work. That's important. Following the independent practice, log on to Dreambox and complete 2 lessons to strengthen your math skills. So for our future connections, today's learning objective again was to determine the experimental probability of an event. Tomorrow, we will continue practicing the experimental probability of an event. Now, I'm sure that you too have a cool probability experiment to share, just like Marvin Holmes III did. Please visit the website below to upload your experiment. That way other people in the greater Richmond area can see what we all been doing. So remember that May is Clean Air Month, and this week we are focusing on different things about clean air. Today's resource will help you learn about acid rain, what is being done about it, and what you can do about it. Be sure to visit the resources on your learning plan as we learn about keeping our air clean for ourselves, the ones we love, and our world. And thank you for being my learning partner today. Again, I'm so glad that you came. Stay positive, be safe. I look forward to seeing you tomorrow. And remember, make today so good that yesterday gets jealous.